Welcome back to episode 23. Today we're going to spend some time refactoring requirements. And before we get into the why of that decision, first let's look back at the last episode. So last time we implemented some UX improvements for installing objects. So we now show if an object where it's going to be installed, so where your mouse cursor is hovering over, whether that's a valid location, and we don't allow installing in any invalid locations. So that's a big improvement. However, it took some gnarly code to get there, and the reason for that is that we are currently modeling requirements as an enum. There was a logical choice because those are very simple to work with and they provide you the data you need at hand through associated values. But we see checks to see if requirements are met popping up at different locations now. So they are in entity and in view model. We see switch statements popping up here and there to look at various types of requirements, and even worse, we see some duplication of logic, not just code. And let me give you a quick example of that. So let's open Xcode. Open up our project, and let's go into our entity, where we check for all these requirements. For instance, we have this object requirement here to see if there's a specific object, not if a location is doesn't have any object here yet. And we find sort of similar code also in object to see if we can build in the world. And we see something similar in our view model when it comes to the where we're checking for items in the world. So we have an I can meet item requirement. So we sort of see requirements popping up here and there. We're doing checks on these requirements here and there, and there's sort of a duplication of logic. And this is kind of fragile, so it's very well possible that you change it's one place and forgot somewhere else. We do have lots of tests that mitigate some of that risk, but I think it would be nice to spend some time in improving this code. And there are multiple solutions for this, but we will do one of the more obvious ones, and that's using polymorphism. And what does that mean is that we're going to transform the requirement enum into a protocol. So it will no longer be a concrete type itself, it will become a protocol. And we will make all the requirements structs that conform to this protocol. So for instance, if we had the enum case items, that takes as an item stack as an associated value, we will create an items requirement structure that conforms to this protocol. And conforming to this protocol for now means that it only needs to implement one mandatory function, and that's the isMet function. This function will determine whether this requirement is met in this world. We'll look into a bit more when we start implementing it. There are some other advantages doing it this way. So for now, we'll choose to make all these strings conform to custom string convertible. This way we can easily create debug messages, for instance. So let's get started. So this starts with going into a requirement, and we have our enum here, and we need to create a protocol requirement. And as stated, this protocol will require one function, isMet in world function, by an entity, and we'll make this an optional because not all requirements are dependent on entities. And we will pass in a position. So this will be the target position for the job that this requirement tries to meet. And we will return a Boolean value. Also, we will make sure that our requirement conforms a custom string convertible. So everybody needs to provide a description, and we will provide a default implementation. That's a property that simply returns the class name as a string. But we can make more elaborate descriptions, for instance, for certain requirements. So let's start transforming these requirements into structs. And let's start with one of the easier ones. That's a position requirement. So this will conform to requirement, meaning that we need to implement the isMet function. And to see if we meet it, we will first see if this entity was passed in. If no entity is passed in, we assume it doesn't really matter if you're in the right position on it, so we always return true. Otherwise, we return whether the entity.position is equal to the position that was passed in. So that's the first one. Let's quickly get rid of the ones we already implemented, converted. So the second one would be the items. This will be an items requirement. This still has an isMet function, but this one has some more information. This one is an item stack. So this is the associated value that was passed into the enum. We now create and pass it in as a property of the structure. So we have our isMet function, and first we need to see if we have our entity. And then if we have it, we can say return the entity.inventory for this specific whether that one is at least as large as what we need in the item stack. So this is what we will return if an entity was passed in. This is when we assume that this requirement applies to an entity performing the job. We also use this requirement for jobs that don't yet have an entity associated with them. And then we check if the world.itemCount, the item stack, .item is at least as large as the item stack .round. So this is the case where we're checking if there is enough of this item somewhere in the world, perhaps somewhere that an entity could pick up. Then for this one, I would like to create a custom description. So we'll go with an items requirement, but we will pass in the item stack.item.name and the amount that we need. So we get some more information when we're using this one in the debug message. Then we have the position requirement. Oh, we already did this one. Let's get rid of this one. So the next one would be the no object requirement. So this takes a vector for the size. We can have our isMet function. And this time we're checking if there is any overlap for all the tiles that this object is large. This isn't the most efficient way of doing it because you're checking many of the same tiles. It would probably be better to do checks based on bounding boxes, but it doesn't really matter from that much from performance point right now. And if it does at some point in the future, then you can always refactor this code further to make it more performant. So we check if an object exists at this position. And if it does, we return false. And if we get through all these checks and nothing is, no object was ever found, then we return true. Now let's see what's the next requirement. That's a tile requirement. So we have allowed tiles. And we have a function is met in world. So let's get a tile from world tiles at position with the default value of a void tile. And then we check if allowed tiles contains this tile. Let's continue. So then we have that's the next one, the object requirement. So we have an object requirement. This takes an object name as a string. And again, we need to implement a function. And this time we will first check let's check if there is an object at this position. I don't think we need to check for the entity's position here. Then but if we can't find an object there, we return false. And otherwise, we need to check if the object name equals the object name that was stored in this requirement. And finally, we have the no item stack requirement. So we have the no item stack requirement. We have our existing stack enrolled to the items. The position, else, return true. There's nothing there, then we can directly return true. Otherwise, we need to check if the existing stack amount is equal to 0. So that's it for converting all the enums cases into structs. Most of this code we now typed in directly. We could have also probably copy-paste them from other places. The first thing we should do is try and build, and we'll see that there will be lots of places where we are passing in enum cases, and now we need to pass in our new structs. So this is a bit tedious. It's not difficult, but it's just a lot of work. So we need to change all these ones where we have, let's see, a position requirement. We have our tile.items requirements. We jump to the definition. It would probably be better to simply return an array of items requirements, and we need to change this one into an items requirement. And it's really just a lot of search and replace. And we need to be specific on the type here that this is a requirement. Otherwise, it expects requirements to be of type position requirements because we initialized it like this. Let's see, we will probably have some more here. So we have no object requirement. We have an items requirement. We have a position requirement. We have a tile requirement. And we have a no item stack requirement. Let's see if we have some more places. So in our recipe, we have a position requirement and an object requirement. And here we create items requirements. We have our view model. We'll get back to that in a bit. First, let's go into our world. So we were making these room jobs. Oh, this is in our demo world. We don't use this anymore. So let's just get rid of this for a bit here. And we have our can meet item requirements. So we have our requirements. This is now an item requirement, and let's start using this new one. So let's see if item requirement is met in the world by, we don't have an entity yet at any position. It doesn't really matter where we check. If this one is false, then we return false. Otherwise, we return true. I think the world is an optional here. I think we need to do is guard that world, else we return false. Okay. Let's continue. So there's more that isn't, but it's unfortunately not really helping me tell where the next error is. Typo, return, build. Let's continue. So we have our entity. This has the big checks requirements function. This is doing all the manual requirements checking of functions, and this one we can make a lot smaller. So let's start by saying we have for each requirement in job requirements. Let's comment out all this stuff for now. Instead, let's check if a requirement is met in the world by this entity at job.targetPosition. If this is false, then we return false. Now, if we do this, we're creating a problem that we're checking if a requirement is not met, but some requirements can be met by creating a new job, such as a position requirement can create a move to location job, and we're not using that anymore. So we need to be a bit more explicit here. Let's create, we need to check for item requirements. So if this requirement is an items requirement, then we can, let's see where we have it, spawn a fetch job. We check if items requirement is met in the world by this entity at the job.target target position. If this is false, then we try and spawn a fetch job. And the rest of the code can stay the same. And we do something similar for the position requirements. Is a requirement as a position requirement. If position requirement dot is met in the world by this entity at the target position. If this is false, then we need to create a new job. And here too, we need to create a return false, even if it was not possible to create a fetch job. And finally, we can do the last check for all the other requirements types. And now I think we can get rid of all this stuff. Let's see, so there are some more where we're doing this. We need to process requirements. This one also needs to change a bit. So for now, this only applies to items requirements. So let's create them for each item requirement in requirements. Where we filter out only the ones that are items requirements. Then we can say consume items, items requirement dot item stack. And let's see what's going. That should be an in. And then we can get rid of the other one here. Okay, let's see if there's where more we have these stuff. So let's see, we have our check requirements. We need to have the item stack here. So let's get the item stack from items requirement.item stack. And we need to get the inventory amount. Okay, so it's building. So we're going further as well. Let's try and run our tests. Because these also will require changing of the code. So this should be a position requirement. And this one as well. This should be an items requirement. Let's look for the next ones. So it's not really difficult, it's just work. Let's see, we have a test here that checks if we have a position requirement, and we can do that by checking if greater than job.requirements dot compact map as position requirement if this one is bigger than 0. And we'll probably have some more like these. So something similar for item requirements. Let's see, we're getting the first item requirement. Where we have this requirement, I think it's easier to simply filter out all the items requirements. And get the first one from this. So now we should have an items requirement here. And then we can check if the item stack has the correct amounts. And let's continue. We have something similar here for the object requirement. And then we have the object name already in the requirement. Let's see, we have some requirements here. Okay, so this should be an items requirement. Position. An object requirement. Okay, it's building. The tests are now running. Let's see what's happening. And our tests passed. So we now reach the point that we have what we had, just with some first refactoring of code. Let's also see if the actual application works as expected. So let's see if we can build some flooring. So that seems to work. Whether we can install our kitchen counter at a valid location. The entity is still cooking, so this also seems to be working correctly. Let's continue, because we haven't really touched the code I wanted to change the most. So first, let's go into our object that has a canBuildInWorld function. And that's hard-coded now, checking for overlap of items. And we have a requirement for that. So what I want to do is this. I want to go and create a test job. So we create a sort of temporary job. This will be a create install object job of this object at the position. And then we check for each requirement in this test job requirements. If the requirement is met in the world without any entity at this position, if this somehow is false, then we return false. Otherwise, we return true. This way we can check for more than just positioning. So let's see if our tests still pass. And one test failed. So let's see what's going on there. So we check if we can build in this world. And I think the thing is that because we're checking for all the requirements, we also need to make sure that our world items at some position has an item stack for the test object.item and an amount of at least one. So let's see if this helps. I think it's called the object item. And now the test passes again. Let's see if we can do something similar in the view model. We have our can meet item requirements. We already changed this one, but that's now, I think, okay. Let's see, there's one final thing I want to do. If we go into our entity and I check requirements, I think I want to, this creating a fetch job, I think I want to create and put this into, extract this into a separate method, because this is just a bit, a lot of code with additional nesting, and I think we have nesting enough so far. So I think what we should do is we should be able to use refactor and then extract a method. And we can give this method a name. So let's call it tryCreateFetchJob. That takes an items requirement. Well, let's say let's do it like this. We say we want an item stack. And we want to do this in the world. So now we don't need this one here. We should have everything here that is required. It's getting called here, but we should pass in for the item stack of the items requirement in the world. So this should still compile. This should still work the same, but I think it makes this function a little easier to read and a bit more obvious what this one is doing. So I think that's it for our refactoring for today. There's a lot more that you could spend ages refactoring this code and make it easier, but I think this will be enough for now. I think next time we should be doing some more work on the game, and I want to look at canceling jobs, because when you schedule a job, let's say you create some flooring, but you're not happy with this, well, tough luck, you can never cancel these jobs anymore. So I want to add some UI functionality that you can cancel a job. That's it for now. Thanks for watching and have a good day.